longer because we need as much time as we could possibly get. So our assignment for today is about half of the word problems that are remaining in this lesson. So I want to be able to go over as many of them as possible. So we're going to get busy. So we are on page 408. And we stopped at number 8 yesterday, so we're going to pick up 9. And I think that I have for your assignment today problems 9 through 15. So my goal is to to at least set them up with you and solve a few of them. We probably won't have time to solve all of them together, but I'll make sure that we go over every possible scenario as far as solving for the unknown, just as a refresher for some of you guys. So, number 9. So let's read the problem. We're going to start them out just like we did yesterday. We're going to read the problem in its entirety, try to get a scenario in our head of what is going on, and then create a diagram of the problem and try to piece together that right triangle, okay? The only difference is today we're going to go all the way to the end and actually solve for that unknown portion, okay? So we are working on assignment 8.4B, and we are going to work on numbers 9 through 15. So, number 9 says, to get to a friend's house, Patrick first drives 5 miles directly south. Then he turns right and drives directly west until he reaches the house. According to his odometer, the entire trip is 13 miles. What is the angle from Patrick's house to the friend's house? Okay, so this is number 9. Okay, so here's Patrick at his house. Okay. And it says that he drives 5 miles directly south, okay? So on paper, south is down, and he went 5 miles, okay? And then it says he turns right and he drives directly west, okay? So then he turns right and he goes west, which on paper is left, and then he reaches his friend's house. So here is friend's house. According to his odometer, the entire trip is 13 miles, okay? So that means from here all the way to here is 13 miles, okay? So if he's driven 5 south, then that leaves how many? Wish you guys were here. 8, a whopping 8. So he went 8 miles this way, okay? Because the total has to be 13, and we knew the 5, all right? So the question is, what is the angle from Patrick's house to his friend's house? So here is our right triangle, and the question is, what is this angle? So this is our theta. This is our reference angle, okay? So if you want to see it without all of the extra stuff. 5 miles, 8 miles, and theta. So we have to find the measurement of this angle right here, okay? That's the question. So in relation to this angle, we are given opposite and adjacent. So out of our 3 trig functions, we know that we have to use tangent, because tangent is opposite over adjacent. So tangent of theta equals opposite, which is 8 miles, over adjacent, which is 5 miles. Okay, so we've worked with this long enough. we know that we're looking for this angle, okay? So this is when we did this step, the inverse function, okay? And so what we do to one side, we do to the other, okay? You don't have to write this step on paper if you don't want to. If you know, just looking at this, I'm looking for an angle, I just need to shift tangent, okay? Then you can do that. Then you can just put your pencil down, pick up your calculator, hit shift, tangent, and then punch in your fraction, okay? So, I actually remembered my calculator. So shift, tangent, and I'm punching it 8 over 5 equals, okay, so this is what it equals. Theta equals 57.99461679 degrees, okay? So now I need to look at my directions and follow instructions as far as rounding goes. So the instructions say to round answers to 2 decimal places. So it's really important that I follow directions. So that means something is happening to this guy, the one in the second spot. Either it's going to stay a 9 or it's going to round up to a 0, and then I got to go next door and do some rounding there. Okay, so but behind this 9 is a 4. So that tells me that it's going to stay a 9. Anything 4 or smaller stays. So theta is approximately 57.99 degrees. So that's the angle between Patrick's house and his friend's house, okay? So this is what I'm looking for on these problems, all right? So let's set up number 9. I'm gonna set it up and then I'm gonna leave it to you to solve it, but let's at least get it set up on paper. So you can see we're just doing what we did yesterday. We're just taking it one extra step. So number 10. All right, so Gary is lining up his foosball player for the winning goal shot. Gary decides to aim for the far edge of the goal, which is 14 inches to the right and 17 inches in front of the ball. At what angle should Gary shoot the ball to make it hit the far edge of the goal? Now, we all know that when we play foosball that we do all this kind of, math, I'm sure, but, just for the sake of fun. So we have a goal. So let me make a picture here. So on a foosball table, it's kind of a slot. So here's my goal on my foosball table. And he's aiming for the far edge of the goal. So let's say this is where we're going to aim, okay? And then here's the ball. And here's what we know about the position of the ball. We know that it is, that the goal is 14 inches to the right of the ball, okay? So let's do 14 inches here. And the goal is 17 inches in front of the ball. So, kind of sloppy. Okay, so we have the ball is 14, or the goal, let's do it this way. The goal is 14 inches to the right of the ball. Here's our foosball, and it's 17 inches in front of the ball. At what angle should he shoot the ball to make it to the far edge of the goal? So we're looking for this. What is this angle right here? All right, so if you need to extract it without all the other details, it looks like this. So we're looking for this angle, we're looking for theta, so we just have to, in order to determine which trig function we need to use, we have to look and see what parts have been given to us. whether it's opposite, adjacent, hypotenuse, or whatever. So of this right triangle right here, I have adjacent and I have opposite. Well, again, opposite and adjacent mean tangent, okay? So the tangent of theta equals opposite, which is 17 inches, over adjacent, which is 14 inches, okay? Hopefully you notice that I'm always inserting my units into my problem. Whether you abbreviate it or not, it doesn't matter. You certainly can, okay? So this is another scenario just like the last one. I'm looking for theta. I'm looking for how many degrees this angle is, okay? So you just have to remember, anytime I'm looking for a degree, you have to shift your trig function, shift sine, shift cosine, or shift tangent, okay? You shift to find your degrees. That's really, like, if you can just remember that, then that'll keep you pretty straight, okay? So I'm just going to shift on my calculator, shift tangent, and then I'm going to punch that in, and then I'm going to write it out, and then I'm going to round, okay? Round to 2 decimal places, okay? So I'm going to let you guys finish that one. Let's move on to the next one. Okay, number 11. So let's read the whole thing. Lindsay is about to sled down a snowy hill that has a 34-degree incline. If the hill has a vertical height, vertical is up and down, has a vertical height of 28 feet, what is the distance of the sled ride down the hill? Okay, so here we go. Let's see, what number? This is 11. All right, so here we go. We have a vertical, here's my hill. We have a vertical height of 28 feet. So this is 28 feet, okay? Don't forget to include your units. And the hill has a 34-degree incline. So that goes there. What is the distance of the sled ride down the hill? This is going to be the sled ride down the hill, right? So this is my x. That's what I'm having to find. So now, go to your reference angle and see what parts you have in relation to your reference angle, okay? So this is my reference angle. I have opposite and I have hypotenuse. So that tells me which trig function I'm going to use. Opposite and hypotenuse means that I'm going to use sine, okay? Because sine equals opposite over hypotenuse. So the sine of, it's not going to be theta because I know my angle. It's 34 degrees. The sine of 34 degrees equals opposite over hypotenuse. Opposite is 28 feet. Hypotenuse is x. Okay, now this is just basic algebra, all right? So I'm solving for x. Now, x is in the denominator, and I can't solve for x while it's down in the denominator, so I have to get him up to the numerator, okay? So I'm going to multiply both sides by x, okay? That is going to get him out of the denominator, all right? So I multiply both sides by x. That gets rid of that guy. So let me just clean it up a little bit. I've got x times the sine of 34 degrees equals 28 feet. Okay. Another way that you can look at it is like this. Let me just sidestep here. If you didn't like this move and if this didn't make any sense to you, you can always look at it like this. You can stick him over a 1, make him look like a fraction, and you can cross multiply, okay? Then you would multiply these, and you'd multiply these. You're going to end up here at the same place, okay? So whichever way you need to look at it to make sense to you is fine. Okay, so I'm trying to solve for x, okay? X is being multiplied by the sine of 34 degrees, so I have to do the opposite, okay? So I just divide both sides by the sine of 34 degrees. What I do to one side, I do to the other. Okay, that gets rid of that. They cancel, leaving me with just x. And now it's just a matter of punching this into your calculator, okay? 28 divided by the sine of 34. Yeah, I mean, you type it in just like that. So I've got 28, and either the division or the fraction sign, whichever, same thing. And then you just hit sine, just go straight to sine, because I have a degree. I'm not looking for a degree, so I don't shift. I have a degree. The sine of 34 equals, okay, so x equals 50.07216662. Okay, and this is actually feet, because I'm looking for a length, okay? Now, x is approximately, I was told to round to 2 decimal places, so this is the guy that I'm looking at. It's either going to stay a 7 or it's going to go up, so I look behind it. That's just a 2, so the 7 stays a 7. So x is approximately 50.07 feet. So that's about how long that sled ride is going to be for Lindsay. Okay, hopefully everybody's hanging with me. I know we're going fast, but I just want to make sure.
Ryan says it did not work for him.
What didn't work? You got to tell me, Ryan. You got to talk to me. What didn't work? The calculator? You got to give me more information than that. And I may just have to let you come back to the video later and re-watch it and follow my steps again, because I know there's going to take a while for communications to come through, and I don't know how much time I have. Well, you can't do both. It's one or the other. Fractions mean division. You pick one or the other. Either you hit the division symbol or you use the fraction key. You got to pick one. Okay, number 12. All right, so let's read it. Samuel is about to go down a slide that is 11 feet tall, so that's your vertical height, and has a slide length of 17 feet. So what is the angle of inclination from the ground to the slide? So this is going to be pretty basic. Okay, so like this is my slide. These are the steps going up, that you have to climb up to, and here's the actual slide that you're going to go down. Okay, so he's about to go down a slide, so Samuel's up here. Okay, there's Samuel. So let's see, the slide is 11 feet tall, so that number goes there. And it has a slide length of 17 feet, so that goes here. So the question is, what is the angle of inclination from the ground, this is the ground, to the slide? So that would be this angle right here. What is it? So that's theta. Okay, so I know, I've already got it in my head. I'm looking for an angle. So I know that I'm going to have to shift something. Shift sine, shift cosine, shift tangent, whatever it is that I have, I've already got it set in my head. I'm going to have to shift because I'm looking for a degree, okay? So let's find the parts of this right triangle that we have in relation to our reference angle. So we have opposite and we have hypotenuse. So that means that we're going to use sine. Okay, sine is opposite over hypotenuse. Again, hopefully you have these memorized by now. So I know I'm going to use sine. So the sine of theta, sine equals opposite, which is 11 feet, over hypotenuse, which is 17 feet. Okay? Now I need you guys to be paying attention. I don't have 100% of you paying 100% of attention to details here. Okay? It's important that you have theta representing your angle. It's important that your formulas have an equal sign in them. And it's important that you have units in your problem. Okay? I've got some of you guys that aren't paying attention to details. So it's not like the math is hard. I mean, this is just simple division and simple multiplication, very basic transposing of algebra work, okay? But some of you guys just aren't, you're not being attentive, okay? So let me encourage you, school's not quite out yet, so don't check out on me quite yet, okay? Pretty soon, pep talk. All right, so from here, I would just pick up my calculator, hit shift sign, and then punch in 11 over 17, okay? It's going to give you a big, long decimal, and then you give me the approximate, and you round to 2 decimal places is what the directions say. So it's really important that we follow directions, okay? So I'm going to let you guys finish this one. It's pretty basic. Bless you, bless you. Okay, so let's move on to the next one. So we are on number 13. All right, so let's read it. Let's get a picture. Each outer pole of a circus tent stands vertically, and it is secured with a rope that is tied to a stake in the ground. The angle formed between the rope and the pole, okay, so that would be the rope and the pole, is 31 degrees. If each pole is 12 feet tall, what is the distance from the top of the pole to the stake? Okay, so let's draw a picture. We have a pole with a rope that's attached to a stake. Okay, I'm not going to try to draw a circus tent because it wouldn't look anything like a circus tent. Okay, so here's my pole. Okay, here's my pole. And here's the rope. And here's the ground. Oop. And then here's my tent stake right here. Okay? So hopefully that makes sense. And there's a big old circus tent over here, but we'll leave that out of the picture. Okay, so let's stick some numbers in here. So this is the pole of the circus tent. It stands vertically. It's secured with a rope that's tied to a stake in the ground. The angle formed between the rope and the pole, so that's talking about this angle right here, because there's the angle between the rope and the pole. It is 31 degrees. And each pole is 12 feet tall. What is the distance from the top of the pole to the stake? So that would be our x, okay? So if you want to extract, if that's too busy for you and you want to extract a right triangle, that's what it would look like, okay? So if this makes sense to you, if you can see the right triangle on there, that's fine. But if it's a little too busy, then you can always extract that right triangle and just kind of simplify it a little bit, all right? So I'm looking for a length, okay? So here's my reference angle. So I just have to decide what parts I have in relation to that angle. So I have adjacent and I have hypotenuse. So that tells me that I'm going to use cosine. So the cosine of 31 degrees equals, so cosine equals adjacent, that's 12 feet, over hypotenuse, which is x. Okay, so I'm going to let you finish this one. You're going to work this one out exactly the same way that we did 11. Okay, and number 11, I worked through it completely. So just follow the same steps. Okay, you're just solving for x, and you're going to tell me about how many feet it is rounded to the nearest 2 decimal places. Okay, so again, don't forget your degree symbols. Don't forget your units on your lengths, okay? I'm saying this over and over and over again for a reason, I promise. Okay, because it's getting forgotten. All right, so number 14. We just have 2 more to set up, but I want to work out the last one with you because I have a rounding rule that I need to teach you. So, unless you've learned it in science, I don't know, maybe you have. So number 14, in an attempt to measure the width of a river, a survey crew finds two trees directly across from each other. The crew walks 20 feet parallel to the river and measures the angle at that point as 73 degrees. How wide is the river? So here's the river, just to kind of give you a picture. They found 2 trees directly across from each other. Okay, and it says that they walked 20 feet parallel to the river. So let's say they started here right next to the tree. I know it looks like they're up in the top of the tree, but it's on the other side of the tree. So, okay. So they walked 20 feet parallel to the river. And it says they measured an angle at that point. Okay, so we're going directly across from one tree to the other. And the measure of that angle, I think it said was 73 degrees. Yes. So the question is, how wide is the river? So this is what I'm looking for, okay? So that's a very busy diagram, so let's extract that right triangle. So this is 20 feet, this is a 73-degree angle, and I'm looking for that part of the right triangle. So in relation to this angle, I have opposite and adjacent, so that means that I'm going to use tangent. So the tangent of my angle, which I know is 73 degrees, so I don't have a theta. I actually have that number. You know, theta just represents that angle measurement if we don't know it. So the tangent of 73, tangent equals opposite over adjacent. Okay, so now all you got to do is solve for x. Okay, so to get x by itself, right now x is being divided by 20 feet. So to undo that, to get rid of it, you do the opposite. So you'd multiply both sides by 20 feet. Basic algebra, and there's your answer. Okay, so you got to tell me x equals however many feet, and then tell me x is approximately whatever that is rounded to 2 decimal places. Okay? So show me both. Show me what x equals exactly with the long decimal, and then show me x is approximately, and then give me your rounded number. Be sure to include your units. I know I sound like a broken record. Okay, so last one. Hopefully we can squeeze in one more. Okay, 15. For a science project, a student stands 25 feet from the base of a tree and determines the top of the tree to be 51 degrees from that point. If the student is 5.5 feet tall and measured the angle from a standing position, what is the height of the tree? Okay, so let's draw a picture. So here's my student. here's the science student. This student, he's very happy, okay, is, let me do this, is 5.5 feet tall. Okay? And here's the tree. And let's see, he stands 25 feet from the base of the tree. So the distance from the student to the tree is 25 feet. Okay? Hopefully you're following me here. Okay. From a standing position, the angle from the student to the top of the tree is 51 degrees. So that means from him to the top of the tree is 51 degrees. Okay? It told us it was from a standing position, so that's at the top of that 5.5 feet. So that's where our right triangle falls, okay? And let's see, what else are we given? The student stands 25 feet from the base of the tree. The top of the tree is 51 degrees from him standing, and he's 5.5 feet tall. This angle is from a standing position. What is the height of the tree? Okay, so this is what I'm looking for ultimately. I'm looking for this measurement right here. Okay? Now, let's go back to our right triangle. Okay. I know, so let's extract it because this is a very busy. Okay, so here is the 51 degree angle. If from here to here is 25 feet, then from the top of his head to the tree is also 25 feet. And I'm trying to find the height of the tree, so let's find this section first because that's part of our right triangle. So let's find this. Okay, that's going to be step one. So in relation to this angle right here, I'm looking for opposite and I'm given adjacent. So opposite and adjacent, that means tangent. Okay, so I've got the tangent of 51 degrees equals opposite, which is x, over adjacent, which is 25 feet. Okay, hopefully everybody's still with me. Okay, so to solve for x, x is being divided by 25 feet, so I just do the opposite, so I'm going to multiply both sides by 25 feet. Okay, so this is just your calculator. So you go 25 times, and then you hit the tangent of 51 equals. All right, so x equals 30.87242891 feet. Okay? Now, that is the measurement of this right here, okay? Only this, x equals this whole long big number here, okay? Now, the question though is, how tall is the tree? Well, this is only a portion of the tree. We still have 5.5 feet that we have to add to this length right here, okay? So, here's the rounding rule that you need to know. You don't round until you're completely done with the problem, okay? Because if you start rounding midway in a problem, you're gonna get off in the end. So you hang on to that big number until your very final answer, okay? We're not rounding yet, all right? Because it will get you off. So I need to add this length, okay, which is this number right here, okay? But I need to add this 5.5 feet to find the length of the whole tree. So I'm going to go 30.87242891 plus 5.5. Now, this number should already be in your calculator. Don't retype it, okay? The more that you retype numbers, the greater chance you have of making a mistake, okay? So leave that number in your calculator. Don't clear it out. All right. So then from here, you can just go plus 5.5 equals, okay. So we've got 36.3724281 feet, okay? Now that we've added all of our numbers, now it's safe to round, okay? Again, don't round mid-problem, all right? So the height of the tree is, so the tree is approximately 36.37, oh, that's ugly. It's an ugly 3. 36.37 feet. That would be your final rounded answer, okay? So we're out of time. At least we were able to get through them all. We got them all set up. If you get stumped, at least you have this video that you can go back to and watch again and just pay attention to the steps. You know, the problems that we're going to do tomorrow are going to be very similar to this one, where they're going to require more than one step. So if you need to, you know, just take your time and revisit the video and just let it sink in, you know, even if you need to watch it a couple of times, you know, just let it make sense to you, however many times you need to watch it. So you should have everything that you need. They're all set up, all the problems are set up. It's just really basic algebra, okay? Please don't forget, if your answer is an angle, give me a degree symbol. If your answer is a length, give me a unit, and round according to the directions, okay? So I'll see you here tomorrow, and we'll finish this up.